Alright, if you missed today, here's a brief summary of lesson number 1. This unit is called quadratics. All the notes for this lesson can be found at macintosh.net/algebra2. But if you found this, then you should have found the notes and the assignment. Your assignment was problems 8 through 14 on the assignment sheet on this page or web page. Okay, so what we talked about today is the general form of all quadratic equations, and all quadratic equations have this form. They've got a quadratic term, ax squared. Some of them have a linear term, bx, and some have a constant term. But the key thing is, if you are a quadratic equation, you have got to have an x squared term in you. That's why we have this statement, a cannot equal 0. If a was 0, you'd have 0 times x squared, which is 0. You would not have that x squared term. Both of these are quadratics. The top one is what we'd call a quadratic equation. This bottom one is a quadratic function. And the quadratic functions, when we graph them, they make this curved shape called a parabola. Okay, and you should be familiar with those, but we're going to discuss some of the parts of parabolas a little bit later. In the standard form here, whether it's an equation or whether it's written in function notation, look at the order things are written in. They're always written with the highest degree term first, the quadratic term, then the second highest, the linear term, and then the term that doesn't have any variable in it. It's important to note that these are all quadratic equations, something like this, 3x squared plus 4x. That quadratic has no c term. You could have a negative 5x squared plus 2. That quadratic has no b term, doesn't have a bx, has an x squared and a constant, and y equals a half x squared. It only has a quadratic term. So all of those are quadratics, and they're also all written in standard form. It's important to be able to write them in standard form so that we all agree on what the equation is. Okay, so that's the first thing. Let's talk a little bit more about parabolas and their parts. Parabolas, if they are functions, are going to open one of two ways. They're going to either open downward, or they will open downward, or they'll open upward. And you can actually tell from an equation whether it opens up or down. The equation for this one right here, you can see it on the screen or on the graph. It's x squared minus 2x plus 3. The a term here, the a coefficient, is negative 1. If a is negative, the parabola will open down. I don't know the equation for this parabola on the right-hand side, but clearly it has an a that is bigger than 0, or that is positive, because it opens up. So the a value tells us if it's going to open up or down. Positive a opens up, negative a, it opens down. Now, some of the parts of the parabola. First thing, let's point out this point right there. Let's go ahead and make that graph a little bit bigger so you can see it. Okay. We're going to just grow him a little bit. Okay. This point right there, it crosses the y-axis, so that's a y-intercept. It's going to be helpful when we try to graph these things. These points there and there, those are x-intercepts. That's where they cross the x-axis. Let's show you corresponding parts on this other graph. On the graph to the right, the one that opens upward, there's its y-intercept. That would be at 0, negative 1. And its x-intercepts are right there at that point, that big dot, and at that point. Okay, those are x-intercepts and y-intercepts. The x-intercepts have several names. Besides x-intercepts, they're also called the zeros of the function. They're called the roots of the function. And they're also called the solutions of the related quadratic equation. So you'll hear those words used interchangeably throughout. Okay? The next thing is we want to discuss where the vertex is, and the vertex is that highest point or that lowest point on the parabola. Each of these have a vertex. In fact, all parabolas have a vertex. Okay, so in this case, up here is the vertex. This vertex is a highest point, so we call it a maximum. And the maximum is the highest y value it goes to. So the vertex here would be, you would say, is at -1, 4, and the maximum is 4. That's the highest y value it goes to. When it opens upright, here's the vertex. That vertex is at 1, -2. This parabola has a minimum, a lowest point it goes to. That lowest point is -2. Okay, so we can tell right away. Let's give an example here. Let's say y equals 3x squared plus 4x minus 5. When I'm given an equation, I go, hey, you're quadratic. I look at the a value. A is positive. That tells me right away it opens up. And it also tells me, because it opens up, this parabola will have a minimum. I don't know what the value of that minimum is. I'd have to graph it and look at it to determine what that minimum was. But I can tell a lot about it just by looking at the equation. Okay, back to our graphs. All parabolas have a line that they are symmetric about. It goes right through that vertex. Okay, it's that line where if you folded the parabola on that line, the two sides of it would lay right on top of each other. This dotted line that they're symmetric about is called the axis of symmetry. It is an equation, or at least that vertical line is an equation, and that equation is x equals, and whatever x value it goes through. For the graph on the left, it goes through x is -1. That's the equation of that dotted line. On the graph on the right, this dotted line goes through x is 1, so that is the equation of the axis of symmetry. That's essentially it. We talked about the zeros or x-intercepts. If you're talking about them as x-intercepts, you'd call this point 1, 0. If they just said, or you were just asked, what's the root, you would say 1. Okay, this x-intercept is -3, 0, so the root, or the 0, is -3. Just the x value that gives you those zeros. And I think that should cover everything that we reviewed today in class. All your notes and homework is online, so get there and stay caught up.